team conformed by Lucia, Silvia, and Ricardo, and we're going to explain the first problem of the population growth section. In this problem, we get the number of bacteria by this formula, that is mt equal 500e by the exponent 0.45t. In this formula, the t means the time in hours, that will be the x independent, while e is the Euler number with a value of 2.31, and n is the number of bacteria, that will be the y dependent.
So we know that we have to substitute time by 0, that is the initial time. So we have to, we know that any exponential 0 will give us 1. So we have to put 500 by 1, and that will give us a 0,500, and that will be our result.
So we have the first two answers for the first 2 hours, increasing of bacteria, and what we need to do for the increasing percentage is to this step. Okay, so we have the bigger answer, so that is 1229.8 minus the smallest answer, that is 784.15. It equals to 445.65, and this will be divided by 784.15. And finally, this answer, we will have the increasing percentage, that will be 56.83%, and that's our final answer. The question of the problem is to find out the number of bacteria that we will have in 3 hours. So for that, we will do the first step, that is to write n of t equals to 500 e elevated by 0.45 by 3. Then we 500 e we make 0.45 by 3, that is by 3, that, and the answer is 1.35. This is the second step, and the third one is n of t equals, now we need to elevate e to 1.35, that is e to 1.35, it's 500 elevated by 3.85. And finally, this answer will be by 500, and the final answer is 1,928.
For question C, we need to find out after how many hours we will get 10,000 bacteria. So in order to get this, we substitute y by 10,000, and after that we pass the 500 dividing. It will get us a result of 20. So in order to cancel the Euler number, we add a natural logarithm, and after that we have this form of equation. So to find t, we need to find the natural logarithm of 20 and divide it by 0.45.
The graph is going 100 to 100 until give us 500, that is the initial number of the
So
bacteria.
in conclusion, we can find out that this problem is not proportional by itself, but that by every hour it will increase a lot of bacteria. So in the graph it will be a big graph with real big numbers.